Okay, so we're going to look at our notes that are in your notebooks. And if you're at home, you have a copy of these, but they're on our input and output tables. Okay, input just means in, when you think of inputting, putting something in. Output, pulling it out, taking it out. Okay? And inverse, if you hear the word inverse, all that means is they're opposite. They're inverse, they undo each other. And operations, we've learned this year, is kind of like a doctor operating. What are they doing? They're adding, subtracting, multiplying, dividing. Okay? So inverse operations are opposite of each other. They undo each other. They're things that undo each other. So here's what they are. For example, here's the opposite of addition is subtraction. Okay, subtraction undoes addition, just like addition undoes subtraction. That's why we can check answers that way. If we add something, we subtract to check it. They reverse. Vice versa just means it's flipped. It's turned around. So the opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication then is division. So division is the opposite of multiplication. They undo each other. And you will see that in those input-output charts, because if we put a number in and we multiply it to get bigger, and then we look at the bigger number to get the smaller number, we're going to do the opposite. We're going to divide it. This is just some, This is just some vocabulary that you're going to be hearing. And it's really good to get a really good understanding of some of this vocabulary. It'll help you later on in your higher level math classes that you're going to be taking. So variables are just an unknown value. Variables are letters from the alphabet that we use to represent numbers that we don't know. So variable is an unknown value. We don't know what that number is. It is a letter or a symbol, okay? A lot of times you'll see in math they'll use X or they'll use Y. Those are the common ones. We even have them in our area and perimeter charts. We use P for perimeter, A for area, L for length. Those are W for width. Those are all variables because we can input different numbers in there to get different answers. Often used in expressions. Remember, expressions are number sentences without the equal sign. So it's like 5 plus 7. That's an expression. Okay? And they represent a number that can change. They just represent all numbers. And that number can change. And that's why we put different numbers into X to see what it is. Or to Y or whatever it is. You also just heard me talk about an expression. An expression is a phrase or what we call a mathematical phrase or a math sentence. It does not contain an equal sign. That's key. An equation is the same thing. It just has an equal sign and it says what it's equal to. But expressions do not. Combines numbers and operations and sometimes variables. So we're putting together numbers, operations, and sometimes variables. So X plus 3 is an expression because it doesn't have an equal sign. It could be 5 plus 2. That's an expression. Okay? It doesn't have to just have a variable in it. It can be 2 numbers with operations. It could be 2 variables. And we don't know exactly what to do with those. But those are expressions. Just think of them as number sentences without an equal sign. Okay, so remember our input and output chart. So input, think about input, putting something in, taking something coming out. So if our input was our unknown, which is X, think about in our chart, we're putting a number in, something's going to come out. Notice where they write the rule, X plus 5. So we're going to put whatever we put in for X, when it comes out over here, we're going to add 5 to it because this is the rule. Do you see where they set those? So if 2 goes in for x, then 2 plus 5 is 7. Okay? If 15 goes in for x, okay? So then right here what we're saying is we're going to take 15 and we're going to add 5. And what do we get? 20. So here's our input box. If 15 comes in, that box is working inside. It's adding 5 to it. The number it's going to spit out is going to be 5 greater than what we put in. 99 plus 5. Add that to it. We get 104. Pause the video and see if you can figure out the next one. And the rule is you're going to take input of n and multiply it by 4. Welcome back. I hope that you finished filling this chart out. Let's look at how we did. So if we put a number in for n, and the rule is we're going to take n and times it by 4, so my output. So 4 goes in. 4 times 4 is 16. So we're going to multiply 4 to each of these. 9, we put in that box. 9, we're going to take 9 times 4, 36. And 9 times 12, 108. Questions? Hopefully. Pause this video if you have some questions or you need to slow down on it. Okay. Try to do this next one for me right here. If we put 4 in, what are we going to do to get our output? Well, let's see how we did. Well, if we put 4 in, what's the rule? It's going to divide that number by 2, so this number is going to come out smaller if we're dividing. So 4 goes in. 4 divided by 2 is 2, so my output is 2. 16, we're going to divide that by 2, and what do we get? 8. And 18, we're going to put that in for n. 18 divided by 2 is 9. So check and see if you got that correct. Notice that if I'm dividing, my numbers coming out or that we're going to spit out are going to be smaller. And notice that there's nothing really set in stone. Like n, they can put any number in for n. We're just going to have to figure out what's happening. Now on this one's so interesting, and I find it kind of neat because of the way that they do things. But we're going to look at this. This chart is filled out. So in this chart, they want us to find that rule. Give me the rule. What's that function inside here? So if we looked up here, the rule was n divided by 2 here. We looked at this one. We took our unknown, and every number we put in, we multiplied it by 4. On the top one, we added 5. So let's look. So how I like to look at these is I go from the input to the output if I know them. And I say, oh, are we getting bigger or are we getting smaller? We're getting what? Bigger. To get bigger, we're going to be adding or multiplying. So we know our rule is going to do. So let's look. What am I going to do to 1 to get to 4? Well, can we add to it? We can add 3 and we get 4. Or we can times it by 4. Do you see that those are the two things that we can do? But now it's got to be the same rule that goes throughout. So we're looking for a pattern, something that repeats. So, and I noticed that this pen tends to be seen a little bit better, and I'm really sorry about the glare. Hopefully it's not too much in the way where you can see what's going on here. But anyways, let's look at here, and hopefully 2. If we put 2 in and 8 comes out, how is 2 turning into 8? Well, let's try some of these. If I add 3, will I get 8? No, and I know it's something that has to repeat. So what if I multiply it by 4? Because we did that up here also too, didn't we? 2 times 4 is 8. Did that work? Yes. So, but we're going to make sure that that is correct. So we're going to times 4. So 3 times 4 is 12. Did that work? Yes. So 4 times 4 is 16. Here's the interesting one. Pause this video and see if you can find out. If I put n in, what's the rule going to be? Okay, what I noticed most of you wanted to do was put 5 here. But remember, n is not only 5, and when we have a rule, it's an unknown. So at some point it could be 5, but we don't know that it is 5. So we have to just use the letter itself, and that can be kind of tricky. So at n, we take whatever, n represents the number. So what we did was we're taking that number and we're timesing it by 4. So the answer here is n times 4. The rule. So here's the rule that we were looking for. And they like to be a little bit tricky on that, okay? Because normally we were seeing n right here, weren't we? And so that's how they told you, and then n times 4, this was the rule that we are looking for. Remember, the rule is going to have that variable in it, okay? And so that was a little bit of a tricky one. So don't ever just, if it ever puts a variable down here in n, it's just saying all numbers. Don't assume that it's 5. It can be 6, 7, 8, 9, 10, 11, 12, 100, 200, whatever number they want. So just leave it at that variable, that letter. Okay. So go back and rewatch this video. Definitely get this vocabulary down. It's going to help you later on in your future understanding of that math, and it's just going to strengthen your math. And input and output, we love it. Just thinking of numbers, are they getting bigger? Are they getting smaller? What's happening?